Hello. Now welcome to the next lecture for this session, that is the cutting force analysis. Now why this cutting force analysis is necessary? The first point is the determination of power consumption. While designing any machine, we require a motor selection, and for that purpose we require the power consumption. This is basically for the power consumption, and power consumption is determined by using the forces acting on the machine or cutting tool. Next is the structural design of the cutting machine. While designing the structure of machine, the forces are required. Next is to obtain the maximum productivity. This can be achieved by knowing different cutting forces acting on your cutting tool and the workpiece. Now see here, while carrying out this study, we required several analysis, and for that purpose this is shown over here. One single point cutting tool is there. Now this study is related with the orthogonal cutting tool. Now in the orthogonal cutting tool, the cutting edge is perpendicular to your workpiece. So this is your V, that is the velocity, and this is a FC, that is the cutting force acting on the workpiece. Now the relation between this V and FC gives the power consumption. So this is the formula, that is the power consumption is equal to V into FC. But for that purpose, for finding out the different forces or finding out the different analysis, we required more detailed analysis of these cutting forces. There are different forces are acting on the cutting tool and the workpiece here. So for that more detailed analysis, we required we figure out some parameters like this. This is the alpha is the rack angle. So here is the cutting tool cuts the material and it gives the alpha, and the chip flows in upward direction with a velocity Vc. This Vc is the velocity of this chip. It moves in the upward direction, and this F is called as a frictional force. This frictional force is a frictional force between the chip and the tool material, and as there is a frictional force, there should be a normal force. So this is the normal force acting on this frictional force, and this R gives the resultant force here. Now we can find out also the frictional angle. The friction angle is the beta. So the beta can be found out by using the coefficient of friction, that is the mu. If we know the mu, then we can find out the beta also. Now there are several more forces are acting on this system here. So the most important force that is acting on the your plane, that is the shear plane. Now we are considering here the one single shear plane is there, that is the white line is shown over here. This is called as a shear plane, and the angle phi is called as a shear angle. By this relationship we can find out the angle phi, and the shear angle Fs is shown over here. That shear force is acting on the shear plane. There is a one single plane is there. We are assuming that each and every time there is a single shear plane is there, and the shear force is acting on that plane. So this Fs is shown over here, and as there is a Fs, then there is a normal force Fn is there, and a resultant force R is acting here. Now if the system is in equilibrium, then the resultant forces, that is R, is equal in opposite direction as shown here. Now how to find out the Fc here? Now all these forces are set up here. Now how to find out the Fc? For find outing the Fc, we know the resultant position of this resultant force. The resultant force, that is the alpha minus beta. By using this angle, we draw one line, continuous line over here, and we know the Fs, that is your shear force. The shear force, the knowing the magnitude of shear force, we can draw the shear force here. So this is the shear force. We draw a parallel line to the shear force having the magnitude of the shear force, and we draw one line which is perpendicular to the shear force, which touches or which connect to this resultant force over here, and draw one circle having a diameter of this intersection, and that is the, so this is the blue color shown over here. We draw one circle here. That circle is called as a merchant circle. By using this merchant circle we can find out the different forces acting on this. So how, which forces we got there? Fs, R and Fn, that is the normal force, shear force and resultant force. Now how to find out the your cutting force? The cutting force is parallel to the base. So we draw one line parallel to the base, that is the Fc. So the magnitude of Fc we can find out by using this graphical method, and we draw one normal line from Fc to R, that is called as your thrust force. Now this thrust force is very much important while calculating all the forces. So in this way we can find out the Fc, Ft and R, that is the resultant force. So by using this merchant circle we find out your cutting force Fc, we find out the cutting force, your thrust force Ft and the resultant force. Thank you very much.